Hey guys, this is Mrs. Harbin, and welcome to Algebra 1, Chapter 2. We are getting ready to start Section 2.1, and our biblical integration or correlation for this section is Ephesians 6:10 through 18. Finally, be strong in the Lord and in his mighty power. Put on the full armor of God so that you can take your stand against the devil's schemes. Now, we know in our spiritual lives we have to be fully equipped, and if we're missing any piece of that armor or any piece of the equipment, we are not fully prepared. It's the same in math. We've got to be fully equipped with all of the correct vocabulary and understanding and foundational skills so that we can take on these math problems one at a time. Our lesson objective for today is this. You, the student, will identify variables and constants in an algebraic expression. Now, if you don't know what those things are yet, don't worry, we're going to find out today. So let's take a look at an algebraic expression. This expression, 62p, is equivalent to 62 times p. We've already talked about this earlier this year, but when you have two symbols written next to each other with no operational sign, so no plus, minus, subtraction, that's minus, multiplication or division sign written between them, then in algebra, the implied operation is multiplication. So the 62p really means 62 times p, or 62 groups of p. So remember, multiplication is the implied operation of algebra. Let's take a look at some definitions that you need to know. The first definition is a variable, and a variable is a symbol used to represent any element of a given set of numbers. And we really could use any kind of symbol that we want. We could make a smiley face variable if we felt like it, or maybe we want to make a box variable, or a triangle variable. Now typically in algebra, you see the letters X and Y. And there's a reason for those that goes along with graphing. We won't get into all those details yet, but those are the two most common because of how graphs are set up with X and Y. However, a variable can be any symbol that's used to represent an unknown quantity, a number. A constant is a fixed number. So 7 is a constant. 3 is a constant. So if you have this number all by itself, it's a constant. An algebraic expression is a mathematical expression containing numbers, variables, and operational signs. So an expression might look like this, 7 plus x. That's an expression. It has numbers, variables, and an operational sign. Or maybe 8x times 5. That's another example of an expression. It contains numbers, variables, and an operational sign. An expression is not an equation. The difference between an expression and an equation is the equal sign. Equations have equal signs. Expressions do not. Now, when you're told to evaluate an algebraic expression, what that means is to substitute values for the variable or variables and simplify the result. So let's take a look at what that looks like in practice. You've been given the expression x plus 9, and you're being told to evaluate it when x equals negative 5. So what we're going to do is plug in that negative 5 every time we see an x. When I was in school, my math teachers called this plug and chug. So we're going to call it plug and chug. So I originally had an x here, and I'm going to substitute in that negative 5. Now I'm going to tell you to always use parentheses when you substitute, even in simple problems like this. We want to build good habits so that when we get to more complicated problems, we've already got these good habits established. So use parentheses when you substitute. Negative 5 plus 9. We know that we can keep combining that because those are like terms. 9 minus 5, or negative 5 plus 9 is 4. All right, let's evaluate this one. X plus 9 when x equals 1/2. Well, we're going to substitute everywhere we see an x, and we're going to use parentheses when we substitute. So it's going to look like that with parentheses. 1/2 plus 9. Those are like terms, two constants that we can combine, and when we do, we get 9.5. Try evaluating this expression on your own. Pause the video and see if you come up with the same answer. Substitute in that 2. Again, let's use parentheses when we substitute. We can simplify that even more, and our evaluation is 11. Try this one on your own. Pause and hit play when you're ready to check your answer. Substitute that 3 using parentheses, combine your like terms, and you find out that your evaluation is 12. Now let's look at some more definitions. The domain is the set of numbers used for the variable. It's our input. It's the number that we're plugging in, also called our input. The corresponding set of values is called the range. So after we plugged in that input and we got a new answer or a different number, we got the range, which is also going to be called our output. Think of it as a machine. You're putting something in and you're getting something different out. In those previous examples, our domain was -5, 1/2, 2, and 3. Those are the 4 numbers that we input into the expressions. Our output, or our range, is 4, 9.5, 11, and 12. So our domain, again, is input, and our range is output. Make sure you know those terms and their synonyms. Input is a synonym for domain, and output is a synonym for range. Let's do some more evaluation. If C equals 5, then evaluate 10C. Okay, we're going to sub in our 5 wherever there's a C. Notice there are parentheses there. We don't see an operator, no plus, minus, multiplication, or division sign, and we know that the implied operation then is multiplication. 10 times 5 is 50. On your own, go ahead and evaluate. If C equals 10, then what is 10C? Pause and hit play when you're ready to check your work. We're going to plug in that C using parentheses and chug out our answer, which is 100. Nice job. Now, we use expressions when we're trying to solve word problems and other real-life problems. So let's say that C is the cost of 1 pencil. 10C is going to be the cost of 10 pencils. In order to find the cost of 10 pencils, I need to know the cost of 1 pencil. If 1 pencil is 5 cents, then 10 pencils are 50 cents, because 10C, 10 times 5 is 50. If 1 pencil is 15 cents, then 10 pencils are 150 cents, or $1.50, because 10C, 10 times 15, is $1.50, or 150 cents. So you can see we use expressions in many real-world problems. Here are some words to look for as we're translating word problems into algebraic expressions and equations. The ability to translate English words and phrases into algebraic expressions is foundational to success in algebra. You must be able to do this well in order to advance through algebraic units. So let's say you see the sum of a number and 4. How would you write that as an algebraic expression? Well, sum tells us it's plus a number, that's our unknown value, so we can use a variable, and 4, that's our constant. It should look like this, n plus 4. You could have used x or y or a smiley face or a box, but oftentimes when we're trying to pick a variable, we pick a variable that starts with the same letter as the thing we're trying to find. So n for number in this case. What about the difference between a number and 5? Well, we know the difference means subtraction. The number we don't know, so we can use n and 5. So we would have n minus 5, the difference between a number and 5. Try this one, 1/3 of a number. How would we write that? Well, let's find our operation first. Our operation is going to be multiplication. Of means multiply. 1/3 we know is a fraction and a number is our variable. So 1/3 n, or we could even write that as n over 3. Now remember, we don't need to write the multiplication sign here. Multiplication is implied when we see a number next to a variable. What about a number divided by 6? How would you write that one? We're being told what our operation is. We have our variable and we have our constant, so it should look something like this. N divided by 6 using a fraction bar, or n division symbol 6. Okay, try this one on your own. The sum of 3 and 8 times a number. The sum of 3 and 8 times a number. The sum we know is adding. times is multiplication. We've got our variable, we've got a number here and a number here. It should look like this. The sum of 3 and 8 times a number, 8x or 8n or whatever variable you used. What about 8 less than 3 times a number? Hopefully you wrote it this way. What a lot of students do, I see, is write 8 less than 3 times that number. But what this actually says is 3n is less than 8. We need to make sure that this 8 is less than our original number, whatever that may be. This one's pretty challenging. See if you can come up with this one. The opposite of the reciprocal of the square of a number. Sometimes I find working backwards can help. So let's see what we're starting with. We're doing of and of and of. So we have 3 multiplications there. So let's work our way backwards. First we have a number. The square of a number is that little 2 here. So that's the square. And then it says the reciprocal of. Reciprocal just means, remember, we take it from here and we flip it over. So the reciprocal is 1 over into. And then the opposite of. Opposite means to change it from positive to negative. And so we end up with negative 1 over variable squared. Occasionally, you'll have to use variables to solve consecutive integer problems. In that case, we would use one variable to represent the first integer. Consecutive just means the next number. Well, the next one after that is 1 more, so we say n plus 1. And the next one after that is 2 more than the original number, so n plus 2. Sometimes we'll be asked to find consecutive even integers. Well, how far apart is each even number on the number line? It's 2. So if we start with n as our first number, the next number is 2 more, so n plus 2. And the next number is 4 more than the original, n plus 4. If we had one more integer, what would it be? What would the fourth even integer be represented as? Hopefully you said n plus 6. And it would continue n plus 8, n plus 10, for however many integers we needed to find. Now let's think about odd numbers. How far apart are odd numbers on the number line? 1, 3, 5, 7. They are also 2 apart, so we represent those as n, n plus 2, n plus 4, and n plus 6, etc. Now a quick review about some angles. You might see some of these in your problems today. Supplementary angles are straight lines, if you remember supplementary for straight. 2 angles are supplementary if the sum of their angle measures is 180 degrees. So if we have a straight line and we measured that angle, it would be 180 degrees. If we take an angle and we put it here, this angle might be 60 degrees. This angle would be 120 degrees. Because we know that straight lines are 180 degrees, if 2 angles form a straight line, they are supplementary and they measure 180 degrees. So, if you know that angle A is 45 degrees, we could say that this angle is 180 minus 45 degrees, and that would help us figure out the whole angle. If you don't know that angle, you've got a variable. We could say this is angle x, and this is angle 180 minus x. We can use one variable to represent both angles. A complementary angle, as a review, 2 angles are complementary if the sum of their angle measures is 90. So this is a 90-degree angle, more or less. It's not a very good picture. And if I have 2 angles, and they form a 90-degree angle, then they are what we call complementary. In this case, I drew a 45 and 45. We could have 60 and 30. We could have 70 and 20. We could have an endless amount of complementary angles. If one angle is A degrees, then the other angle can be